everybody. I'm Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about principles of green chemistry. Before going to the principles of green chemistry, first we should know what is the difference between the chemistry and green chemistry. Suppose if you take any chemical reaction by using different mechanisms of chemistry. For example, let us take an example for chemical reaction. A plus B gives rise to C plus D. Among these two products, that is C and D, out of these two products, only one product is wanting product. That means desired product. That means the product, it should be very economic as well as very useful in a chemical reaction. At the same time, this desired product formed as a major product in a chemical reaction by comparing another product D. That means desired product is formed in more percentage, that is 90% than another product D, that is 10% of product. So now by using green synthesis or green chemistry, by using different mechanisms of green chemistry or different methods of green synthesis, we can minimize the formation of these unwanted product, that is D. So that is the main difference between the chemistry and green chemistry. So by using or by applying green chemical synthesis or green synthesis methods, we can minimize the formation of these unwanted product. At the same time, economic of the reaction also we can enhance by using green synthesis methods. Now, coming to the definition of green chemistry, how we can define green chemistry? So it is a branch of chemistry which design the chemical products and new processes other than chemical processes that should be eliminate or reduce hazardous substances to the environment. That is it is a benign of chemistry. Benign means new method of chemistry that should be minimize hazardous nature of the reaction. How we can minimize hazardous nature of the reaction? By minimize the formation of unwanted product or less percentage of product. Suppose if you take some chemical reaction, in that particular reaction, both toxic and non-toxic products are formed. By using green synthesis method, we can arrest or we can block the formation of toxic material. That is the green chemistry. Green chemistry is also known as sustainable chemistry, chemistry that is benign by design and prevention at the molecular level. Now coming to what are the main benefits of green chemistry? Lot of benefits is there by using green chemistry and comparing traditional chemistry methods. That is human health, with regard to human health, that is clean air and clean water and clean environment. Now coming to the principles. Now how we can minimize the formation of unwanted products? There are 12 principles of green chemistry. By applying these 12 principles of green chemistry to a particular reaction, we can minimize the formation of unwanted product by applying 12 principles. Let us see what are the 12 principles of green chemistry or green synthesis. That is, first one is waste prevention. Second one is atom economy. And third one is less hazardous synthesis. Fourth one, safe chemical design. Benign solvents and auxiliaries. Energy efficiency. Renewable feedstocks. Reduce use of derivatives. Catalysis. Real-time analysis. And the last one is safe chemistry. Inherently safe chemistry. By applying these 12 principles of green chemistry, we can minimize formation of unwanted product. Unwanted product in the sense the product which is formed in a chemical reaction with less percentage. Let us see one by one. First one is waste prevention. So, it is better to prevent waste formation than to treat or clean up after their formation. That means, before going to the take reaction, first we should assume which reaction is useful and which reaction produce less hazardous products, as well as which reaction can we produce less harmful products to the environment, as well as which reaction can produce more percentage of desired product. So that is the better to prevention waste than its formation after reaction takes place. And second one is atom economy. Atom economy. So it is a efficiency of the reactants. That means how many of the reactants that are end up as useful products. Atom economy measures how much amount of useful products are formed by using reactants. So with the help of atom economy, can we measure the percentage of useful product formed in the reaction. If you see that reactant A plus B gives rise to products B and U. So here P is the desired product, U is the unwanted product. So already we know that atom economy refers to use formation of or percentage of usable product formed in a reaction. So let us take a formula, that is atom economy is equal to 100 into mass of the product by mass of the reactants. Mass of the total products by mass of the reactants. Here what are the products B and U? By divided by mass of the reactants, that is A plus B. Let us calculate atom economy of a different reactions. Okay, look at here. Here two reactants, that is reactant A and reactant B. Reactant A is bromine, react with reactant B, that is ethane, produce 1,2 dibromoethane. So here 160 is the mass of the bromine, 28 is the mass of the ethane. Here product 1,2 dibromobethane is 160 plus 28 gives rise to 188. So if you go for atom economy formula, mass of the product by mass of the or reactants or products. So here what is the mass of the product? 188. 188 by 160 plus 28. These are the mass of the total reactants in a reaction. 188 by 188 into 100. Then we will get 100% of atom economy. So 100% of atom economy indicates it is the most useful reaction and most feasible reaction and most economic reaction. Why? Because how we can say that it is a most useful reaction? If you observe that here there is no byproducts. Here there is no byproducts. Only one product is formed in the reaction. That is 1,2 dibromoethane. So that's why we can say that it is a most useful reaction, feasible reaction as well as most economic reaction. If you take any type of reaction with less number of byproducts, that should be most economic. That should be most useful. So that is atom economy of the reaction is 100%. Next, one more reaction is there. That is ammonia react with sodium hypochlorite, produce hydrazine along with sodium chlorate and water. Sodium chlorate and water. Here hydrazine is the useful product. Commercially very important product. It is used as a rocket fuels. Hydrazine is used as a rocket fuels. So here if you observe that the percentage of hydrazine is 32. Percentage of hydrazine is very less by comparing sodium chlorate. So that's why we can minimize, first we should minimize the formation of NaCl and water by using different green synthesis method. Okay, let us calculate atom economy for this reaction. So here ammonia, the mass of the ammonia is 34 and sodium chloride, the mass of the sodium chloride is 74.5 and next hydrazine, mass of the hydrazine is 32 and NaCl 58.5 and water is 80. So then calculate atom economy of this reaction. Now one more advantage of atom economy is we can identify the reaction, type of reaction with the help of atom economy. So if the reaction with 100% of atom economy indicates that that reaction either isomerization, rearrangement and addition reaction. If you observe that if the atom economy decreases, type of the reaction also changes. So if you see that the atom economy is 0%, then there is no reaction or wrong reaction. If the atom economy is 100%, that reaction is isomerization, rearrangement or addition reaction. That is about atom economy. Next principle, that is third one, less hazardous chemical synthesis. That means if you take the reaction, that should be less hazardous. That means that should be produce less unwanted products. Unwanted products in the sense the products which produce toxicity to the environment. Example, synthesis of polycarbonates by using parsine. Synthesis of polycarbonates using parsine. So here, if you observe that parsine is the highly toxic and corrosive, and it requires large amount of CS2Cl. So here, this is the traditional method. By using conventional method is nothing but green synthesis method. So same polycarbonates can be produced by using some other catalysts or some other reaction conditions and some other reactants along with parsine. Then automatically can be decreases the formation of hazardous products. Let us see. So look at here. Bisphenol react with parsine, produce polycarbonate. If you observe that here without sodium chloride and PTC means phase transfer catalysts, produce some harmful nature to the environment. So here we are going to use aqueous NaOH, PTC along with parsine. Then automatically we can be decrease the hazardous nature of the environment due to the presence of parsine in a chemical reaction. The next principle is designing safer chemicals. Safer chemicals we have to design before going to the reaction. First we should assume which chemicals produce harmful nature and which chemicals produce less harmful nature to the environment. For example, renewable solvent Kyrene. It is a organic compound, but it should be renewable, biorenewable. For example, let us see the example for safe chemicals producing safer chemicals products. So, example, chemicals called organotin. It is the organotin, that is tetraalkyl tin. 4 alkyl groups are joined with tin. This type of compounds are known as organotin. These compounds are used as a anti-biophilic agent. So what are the anti-biophilic agents? These are the chemicals used to prevent the corrosion of a bottom of the boat, bottom of the ships. All these are also used to prevent the accumulation of banagas and marine plants traditionally. So this is example for producing safer chemical products. One more example for designing safer chemicals. TBTO, tributylene oxide. dibutylene oxide. Here, this is also used as a biofluoridants in a marine. And next one is staple solvents and auxiliaries. So here, what is auxiliaries? These are the solvent separation agents. That means if you take some reaction should be takes place in presence of solvents. After completion of the reaction, that solvent should be separated from a reaction. How it will be separated? With the help of some compounds, some chemical compounds, that is known as auxiliaries. So auxiliaries are solvent separation agents. So what will happen? If the solvents are remains in a reaction. Suppose if you take some reaction, A plus B gives rise to C plus D. Here some solvent. This reaction takes place in presence of solvent, like some organic solvents, methanol or chlorine. So after completion of the reaction, products C plus D. This product contains some amount of methanol. So here, methanol is the organic solvent that produce some harmful nature to the environment. Even though here two products are desired products, that means most useful products, and that product should be less toxic to the environment. If you do not if you are not separate this methanol from these products also will become toxic. Automatically, product C plus D will be toxic. That's why these methanol has to be separated from the reaction. That's why we have to use some auxiliaries. So auxiliaries are the solvent separation agents. With the help of auxiliaries also, we can minimize the toxic nature to the environment. And next one is stable solvent and reaction conditions. The use of auxiliary substances, that is solvent separation agents, we should minimize the formation of unwanted products. So examples: water. What is the eco-friendly solvent? We know that. When comparing in a chemical reaction, that is A plus B gives rise to C. Here CH3OH. Same reaction takes place in presence of water. Among these two reactions, second one is the most eco-friendly reaction. Why? Because here we are using eco-friendly solvent water. When comparing first reaction, here we are using methanol as a solvent. Here methanol is organic solvent and produce some extent of hazardous nature to the environment when comparing water in a second reaction. Next one is design for energy efficiency. Energy requirements of the chemical process should be recognized for their environmental and economic impacts and should be minimized. For example, greener antibodies. If possible synthetic methods should be conducted at ambient temperatures. Ambient temperatures. If you increase the temperature in a reaction, what will happen? The reaction will become toxic. That's why whatever temperature required for a particular chemical reaction, that should be ambient. That means room temperature. So when comparing two reactions, one reaction takes place at high temperature and one more reaction takes place at ambient temperatures. By comparing these two reactions, the reaction takes place in presence of ambient temperature is eco-friendly reaction. Why? Because the temperature increases, we can't expect the desired product. That means number of products has been formed along with desired product because of high temperature. That's why we should maintain ambient temperature in a particular chemical reaction. So automatically that reaction should be eco-friendly. And next one is use of renewable feedstocks. Renewable feedstocks. That means renewable feedstocks. What is meant by feedstocks? Whatever byproducts formed in the reaction. Byproducts means some unwanted products, some less important products formed in the reaction is known as byproducts. That products are used as a starting material or reactants in another reaction, that is known as renewable feedstocks. Suppose if you take some reaction, A plus B gives rise to C plus D plus E. Here C is formed 90%, D is formed as 5%, and again E is formed as 5%. When comparing these three products, product C is the major product or our desired product. Then here remaining products, that is D and E. In this reaction, these are considered as waste products or unwanted products. These unwanted products, that is D plus E, used as a reactants in another reaction, F plus G. So now we can minimize the toxic nature of the reaction. Why? Because we know that toxic nature will be generated or hazardous nature will be generated due to the formation of these unwanted products. These unwanted products are we are using as a reactant in another reaction. Then automatically toxic nature will be minimized. That is known as use of renewable feedstocks. For example, carbon dioxide. It is a feedstock used by plants by photosynthesis. So what is a photosynthesis? Production of carbohydrates by using carbon dioxide. That phenomenon is known as photosynthesis. And one more important example for renewable feedstock is use of adipic acid. Adipic acid. So it is one of the reactant in the preparation of nylon 66, which is very important or commercial polymer. This is formed from adipic acid. So if you see the synthesis of adipic acid, it is synthesized by cyclohexene, oxidation of cyclohexene. Oxidation of cyclohexene in the presence of KMnO4 or peroxide. This is adipic acid. Same adipic acid is formed by another alternative methods or green synthesis methods. If you observe that D-glucose in presence of E. coli. E. coli is the bacteria. Convert into dihydrocyclimate. This is also in the presence of E. coli. Convert as cis-muconic acid. Cis-muconic acid. And this cis-muconic acid in presence of platinum and hydrogen forms adipic acid. Biomass feedstocks. And one more example for feedstocks, that is biomass feedstocks. So 6CO2 plus H2O gives rise to C6H12O6 plus 6O2. Whatever carbon dioxide formed in the environment, that is converted into C6H12O6 by sunlight. That's why it should be considered as a blendable feedstocks. Next one is 8th one, reduce derivatives. Reduce derivatives in the sense whatever unwanted products or toxic products formed in the reaction, that should be reduced. How we can reduce the formation of derivatives or byproducts? By using some blocking groups or protecting groups. Let us see. Suppose if you take this reaction, that is starting material and desired product and undesired product. Here our desired product is this one. But in this particular reaction, along with desired product, some unwanted or undesired product also has been formed. Here, by using some protective groups, we can minimize the formation of this undesired product. Look at see. First, we should protect this group by using some catalyst or some reactant. Then this one react with some reactants. This reactant only attached here whatever vacant position present on the reactant. Then after the formation of this is our desired product. The catalyst or the reactant carries lead ore, only one lead ore. That is our desired product. Here, that is our desired product. Reactant carries only one lead ore. That is our desired product. If it is carries two lead ores, that is undesired product or unwanted product. So by using protecting groups, we should prevent the formation of these products. Okay. So after the formation of our desired product, we have to deprotect. That means whatever you are using protecting groups, that should be eliminated. That step is known as deprotection. That is a deprotection. Then we will get our desired product. Look at see. One more example. And next principle is catalysis. What is a catalysis? In a chemical reaction, we are using different types of catalysts. So what is a catalyst? How we can define catalyst? The substance which is used to increase the speed of the reaction, that is known as catalyst. That process is known as, or that phenomenon is known as catalysis. So in a particular reaction, we should select some eco-friendly catalysts or less hazardous nature producing catalyst we have to use in a chemical reaction. Suppose if you take some reactions, okay, here if you observe that in first reaction, here we are using sodium chloride NaBH4 forms some hydroxy compound along with BH3 NaOH. These are unwanted products or waste products. So we had to minimize, we had to prevent the formation of these products. How we can prevent the formation of these products? By changing catalyst. In place of NaBH4, we should take palladium or carbon in presence of hydrogen. Then we will get same hydroxy compound or same desired product. But here there is no waste products. So by using palladium carbon as a catalyst, we can prevent the formation of unwanted products. That is known as catalysis. Next one is design for degradation. Design for degradation. So what is a degradation? Breakdown of the substances by the attack of some organisms, that is bacteria, fungi, or spoilness of the material after completion of the reaction. That means, suppose if you take some reaction, again A plus B gives rise to C plus D. So if you take biodegradable products in a reaction, suppose this reaction takes place in presence of E as a catalyst, that should be biodegradable. So after completion of the reaction, that catalyst has to be degraded. How it will be degraded? By the attack of bacteria or fungi, etc. etc. That is known as degradation. The reaction should be designed as a degradable reaction. So ultimately, we can minimize the hazardous nature of the reaction. For example, some more examples for design for degradation. Biodegradable polymers, PPC, polypropylene carbonate. It is a common example for biodegradable polymers. Next one is 11th one, real-time analysis for pollution prevention. Real-time analysis, that is nothing but in a chemical reaction, time to time we had to monitor. We should monitor the reaction time to time. That is known as real-time analysis. With the help of real-time analysis, we can minimize the pollution or formation of pollution also we can prevent. So time to time monitoring of the reaction is known as nothing but real-time analysis. These are the examples for some real-time analysis. That is, if you take coal, is burnt in the industrial boilers, SO2 is formed. If its temperature of the boiler is too high, a large amount of SO2 will be generated. So then, by using real-time analysis, we can minimize the temperature. If you minimize the temperature, the production of SO2 will be prevented. That is known as real-time analysis. And last one is safer chemistry for accident prevention. The formation of substance used in the chemical process that should be choose to minimize the potential for chemical accidents, including releases, explosions, and fires. That is a safer chemistry for accident prevention. So these are the principles of green chemistry. So by using or by applying these 12 principles of green chemistry, we can minimize the formation of pollution to the environment. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.